Hello, welcome everyone to our RethinkDB 116 release webcast. I hope you can hear me fine. Thank you all for joining us. My name is Daniel, and I'm the Director of Engineering at RethinkDB. With me today is Tim Maxwell.
Hi everyone, I'm Tim.
Tim is actually one of the masterminds behind the new recall admin interface, which we are shipping with this version. And he's going to show us a little bit about it later. So we actually just released RethinkDB 116 this morning, and are really excited about this update. It's one of the biggest updates we have done so far, with loads of improvements everywhere, all over the place in different areas. There are two core areas where we have done improvements. With well, the first one is with respect to our Changefeeds feature, and we have done a whole bunch of extensions to that. To quickly introduce you to Changefeeds, what they allow you to do is to get real-time push updates from your database into your application. And it's really easy to use. So what you do is that you just run a query and you subscribe to it. And once you've done that, the database server is going to tell your application whenever the query result changes. So you can use this really well for building web applications, for example. So one example would be some collaborative text editor or other collaborative applications where you expect multiple users to immediately see if another user has made a change to the data. Another example are online games, which actually we will see some examples about in a moment. The other big area of improvements in RethinkDB 116 is the administration API, and this allows you to manage your cluster very easily and gives you a huge amount of flexibility and control. And Tim is going to talk about that later. Let me first show you a little bit of what you can do with our new Changefeed features. So I've set up a small cluster here with two servers. You can see the two windows here, and I have a small table which I called scores. Let me show you what's in there. So we can see down here that there are a couple of documents, and in each document we have a name, which you can think of as the player name, the score of the player, and there are also teams. I just created two of them, alpha and beta. So each player is a member of a team and has a current score. I'm just hearing there's some audio issues. Can you all hear me? Okay, some of you can. No? Maybe not. Okay. We'll give it 10 seconds maybe if you want to check your audio settings. All right, let's go on. I hope everybody can hear me now. All right. So I'm going to continue, and if you missed the first part, you can join in later. We're also recording this webcast, by the way, so you can play it later and catch up with the missing parts. All right, so we're having the scores table, and now, one of the basic things that you might want to do for an online game is to get the current statistics for the current player who's logged in. So in RethinkDB, I can just do that by, for example, getting the data for Bob. And this is what we get, just what you would expect. Now, let's say at the same time Bob is actually playing the game, so he might get a new score. And let me just copy a write query over here to the second client. So this is going to update Bob's score to 1,000 points. So I'm going to run this, and we can see that it has changed the data. However, here in the other client, we are still having the old result around. And if I wanted to get updated, I have to rerun the query. Let me do that quickly. So now we can see, of course, we have the new result. If you want to do this in an application, what you basically have to do is to do polling and rerun the query, for example, once every 5 seconds or once every second, or whatever frequency you need. So this has a couple of disadvantages. First of all, it doesn't scale very well, because if you have a lot of users connected to your application, all those periodic updates accumulate to a lot of queries. The other problem is that depending on how you set the update frequency, users might actually see updates only with a significant delay, which really degrades the experience. So what we have done in RethinkDB is that we have added Changefeeds, and I can use that on this query just by attaching the changes term. So let me run this, and then we will see how that works. So right now it's just giving me the initial value. That's the same we had before. And now I can switch back to the other client and change the score once more. Let's add another point for Bob. And now I would like to ask you to spend attention on the left side where we currently have the query result. And I'm going to run this update, and we will see what happens. Okay, I'm running it now. And boom, you can see that immediately the database gave us the new result. And the format of these result updates is always that we send the old value and then the new value of the query result. All right, so this was a relatively basic example, just showing the current data of the user. This is something which we've added in 1.16. That is one of the basic features, but really useful for a lot of simple things. However, it doesn't end there. So we have added a lot more complex use cases which are now supported. One example is, let's say you want to get the high score and want to know the score of the best player currently. So you can do that by, instead of doing the get, we are going to use the max term. And if I run this, just talk about the previous one first. Okay, now let's run the new query. This is going to give me the score of the player, the result for the player that has the highest score right now. In this case, this is Bob again. Now again, I can go to the second client, and this time I'm going to update the score of another player. So I'm going to set the score for Eve to 1,100. So we would expect that Eve is now going to have the high score. And indeed, if I run this update, again, look over to the left, and we can see the update coming in there immediately. So this really allows you to update the information that users see on a website immediately as soon as the data changes. We can even do more than that. So this was just the top result. A generalization of this is to use order by. So I'm going to sort the table based on the score, and I want that in descending order, so I have the players with the highest score on top. And there are a lot of players. We are probably only going to be interested in the few top positions of that high score. So okay, I'm running this now, and you can see now we are actually getting the top 2 results. And again, I can update this, update the data, and let's set Michael's score to 1,200, for example, and I hit run. And did I run it? Oh, I actually forgot to attach the changes, so we didn't have a change feed here. Sorry for that. Let me retry that. All right, so now we have a change feed. Now I have already updated Michael, so he's now in position 1. So let's change this and give Eve another couple points. And the sort of update we are now getting is that we can see that the old value for Eve was 1,100, and the new score for Eve is 1,300. And this also works if I update another player that's not even currently in the high score. So currently we have Eve and Michael in the high score that I can update, for example, Bob's score. And since Bob is now going to move up into the top 2, we are also going to get an update for that. And okay, I had this paused. So, but we can see here that it shows up. All right. Another thing that's really neat is that you can apply filters to Changefeeds. Also a new feature in 1.16. So let me clear this out and fetch another query for you. So in this example, we are going to filter by the team. So let's say we want a list of all the members of the team. In this case, we're going to do that for the team alpha. Again, if I run this, we have no changes yet. But now we can add a new player. And I'm going to add Tim as a player over here. And he's going to start out with a score of 1,500 and will become a member of the team alpha. So if I insert this, we will see an update over there. And boom, yeah, we can see that the old val is null in this case. What that means is that Tim didn't previously exist in this result because we've just added him. And we have a new val, which just shows you the new data. The same works in the other direction too. So if we remove Tim from the team, and in fact we are going to change his team to beta, we will get another change here. So this now tells us that the old val was whatever we had before, and the new val is now null, which means that Tim has been removed from the team. And there are a lot of more combinations you can do. You can combine filters, maps. You can do different variations of order by. And this gives you a whole lot of possibilities. You can really run quite complex queries and get real-time updates for all of that. Right.
So, Daniel, I have a question. If people want to find out more about our new Changefeed features, where should they go?
Yeah, so we actually have a lot of information on our website. We have some details in our documentation, and there has also been a recent talk that our CEO Slava gave. You can find a video of that in our blog, together with a lot of additional use cases and background information. So I think that's the first place you might want to look at if you want to learn more about Changefeeds. With that, I would also like to hand over to Tim, who is now going to show you some of the things you can do with RequalAdmin.
Okay, hello everyone. This is Tim here. So many of you who've used RethinkDB before are already familiar with the Data Explorer. So it's this, are you already familiar with the Web UI, which includes the Data Explorer, but also these other tabs that talk about the servers. So we have this cluster here of 2 servers, and we can have a list of the tables and so on. And we can use this administrative interface, this Web UI, to access and manipulate these tables. And this is all still accessible in 1.16, but we've also introduced a Requal API that does many of the same features. So for example, we have this scores table that Daniel was just demonstrating how to do Changefeeds on, and we can use the Web UI to reconfigure it. For example, right now you can see that it's currently only hosted on server A, even though we have 2 servers, server A and server B. And so we could use this interface by clicking this reconfigure button to make it be hosted on both servers. But I'm going to show you how to do that using Requal instead. So if we go to the Data Explorer, I can type r.table scores, and then I can append the new reconfigure command to the end of that. And the parameters I pass to reconfigure are the number of shards and the number of replicas I want in the new table. So I can do shards, and I'm saying I want 2 shards and 2 replicas. And so what it's going to do is it's going to make 2 shards where each of them is going to have one of the tables as the primary, or one of the servers as the primary and the other server as the secondary. And you can see on the left that currently it has 1 shard with only server A as the primary. But when I run this command, we're going to see that change on the left over there. So I click Run, and now it's automatically reconfigured it so it has 2 shards, each of which is using both server A and server B. And this is not all that exciting, because even though you could do this using through the REQL admin API now, you could do it using the web UI before, but there's also a lot of new stuff that is only accessible through the REQL admin API, which was not possible to do through the web UI. And most of this new functionality is exposed through a new feature called system tables. So we have a magic database called RethinkDB. So we can say r.db RethinkDB, and this is built into every cluster. It's not a database you create with DB create. It just is there automatically created by the cluster. And it has a bunch of new tables in it. And these new tables correspond to different aspects of the cluster. So for example, what we just did where we reconfigured the table by moving it to different servers, that's reflected in this magic table called RethinkDB.tableconfig. So if we show the rows of the RethinkDB.tableconfig system table, we see that it has one document in the table for every real table that we have that's storing our users' data. So we have this one document that corresponds to the table scores, and we see that it has a name field that indicates the name of the table, and it has the primary key, and it also has this shards subdocument, which describes how many shards does the table have and which servers are they hosted on. And not only can we use this to see where the table is currently hosted, we can also write to the table config system table to change where the table is hosted and to specifically force it to be hosted on the servers that we want it to be hosted on. So for example, if I were to want to change back the changes that I did before so that it's only hosted on server A again, I could do the following write query. I could update it by replacing the shards field with an array of one shard, and this one shard has the primary replica set to server A and only one replica, which is server A. And when I run this query, then you can see that that's changed the configuration back so the table is now only hosted on server A. And apart from reconfiguration, REQL admin also provides a way to access the current status of your tables through the system table called RethinkDB.tableStatus. So I run this query, and the table status system table is similar to the table config system table in that there is one document in the table for each of your real tables, but the table status table shows what is reads and writes and so on and so on and so on, and are all of the broad whoa, voice went out. Can everyone hear me? Okay, it seems like it's back up now. All right, I'll just rewind a minute. So in addition to the table config system table, which you can use to change the configuration of your tables and to view the current configuration of your tables, we have another system table called RethinkDB.tableStatus, which can be used to show the current status of your tables, whether they're ready, whether they finished doing their backfills, whether they're accepting writes and reads, and so on. And so I just ran this query RethinkDB.tableStatus to list all of the rows in the table status table, and we see that we have this row that corresponds to our scores table from Daniel's demo, which describes which replicas it's currently hosted on and what its status is, and that it's ready for reads and it's ready for writes and so on. There's a lot of other administrative tools along these lines. One particularly exciting new one is the new jobs table. So the jobs table has one document for every running query in the RethinkDB cluster, as well as background tasks like garbage collection or like backfills. And so here we see there's only one document in the jobs table, and this document actually corresponds to the query that I just ran up here. That's why its duration is a fraction of a millisecond. But if I run a long-running query for my other data explorer, I'm going to start a long-running r.js query that's not going to terminate. Oops, I mistyped that. Thank you, Daniel. So I'm just going to run an infinite loop with a timeout of 1,000 seconds, and that's just going to run and run and run and not do anything. And then if I want to find out if I have any long-running queries in my cluster, I can actually filter my jobs table. And this query is going to return all of the running queries in the cluster which have durations longer than 10 seconds. And we see that we have this one row which corresponds actually to the query that we just started over here in the other window. And then suppose we want to kill that query. Maybe we know that it's a broken query, and we want to stop it so it stops consuming cluster resources. We can actually just delete that row from the job system table. And when we run this query, then the query on the left instantly gets killed. It gets interrupted by the system automatically. And so this gives you a more powerful administrative tool that you can use to make sure your cluster is doing what you want it to do. Another cool new system table we have is the stats table. And the stats table shows you statistics about your cluster. So we can run r.rethinkdb.tablestats. And this will have us have rows in the table corresponding to statistics about the cluster as a whole, statistics about each individual server, statistics about the tables, and so on. And we can see things like how much cache is this table using on this server, how many documents have been read from this table on this server, and so on and so on and so on. Another cool new table is the logs table. And the logs table has one document for each log message that is on any server in the cluster. And so we see here, these are the log messages that server A printed when it saw the connection from server B. And we have a whole bunch of log messages in here, and I'm not going to scroll through them all, obviously. A final interesting table that we have is the server status table. And this one is really important because it tells you if your servers are accessible and up right now. Server status. Right. And so it has one row for each server in the cluster, and it will tell you things like, is this server connected to the cluster right now? What is the PID of its process? Which ports is it listing on? And so on. And the most interesting part of this, of course, is going to be whether it's connected or not. So I'm just going to pluck out those important fields. So we see that we have two rows, one for server A and one for server B, and both of these servers are connected. And we can also combine the RequalAdmin API with Changefeeds by requesting a change feed on one of these system tables. So we can get a change feed on the server status system table, and we run it. And then if I were to go over to the terminal where I started server B, and I kill it with Control-C, then we'll see that we'll immediately get an event in the change feed over here saying that server B has gone from status connected to status disconnected. And so, for example, you could use this to write a script that continuously monitors a change feed on your cluster and gets a notification every time a server goes down. And then it can use that to, I don't know, pager a system admin or something like that. All right, so that's the new Requal Administration API, and I'm going to hand it back to Daniel Mewes now.
Thank you, Tim, for this demo. So if you want to try these things out yourself, you can download RethinkDB 1.16 on our website, rethinkdb.com. Also, of course, you can find us on Twitter. We have an IRC channel on Freenode if you have any questions or feedback about the release. We are now going to take questions, and you can type them either in the chat or also ask questions on IRC, and we will try to answer them as well as possible. We also have Michael Lucy joining us now. Michael Lucy developed the new Changefeeds feature. So if you have specific questions about Changefeeds, he's going to answer those.
We have a question already. John has asked, with the changes method, I noticed the update only shows what's specifically updated. Is there a reason why it doesn't show us the entire data set?
Mm-hmm.
Hey, this is Michael. The reason we don't show you the entire data set is, I assume you're talking about the case where you call like .between .changes, and something changes in the range you specified, and we only tell you the document that left or entered the set rather than resending the whole set. The reason for that is just like network bandwidth, basically. Sometimes these sets are big, and if we resent the whole thing every time, it would get pretty ridiculous pretty quickly.
So, okay, another question from Slava for Tim. Could you run reconfigure with dry run and explain how it relates to table config?
Yes. So Slava is asking about one of the optional arguments to the reconfigure command that I demonstrated. I'm just going to bring back up my server B so that I can make this actually work properly. So you remember that earlier we ran reconfigure by saying r.table scores.reconfigure shards to replicas 2. And what this did is it reconfigured the table to have 2 shards and 2 replicas. But if we suppose that we aren't quite sure what's going to happen when we run this, and we want to make sure that it's going to pick a reasonable configuration for the servers for the table when we run this command, we can get a sneak peek at what the command is going to do by passing an optard called dry run. And if we set dry run to true, then when we run reconfigure, then instead of actually applying the configuration change, it will just show us what the new configuration would be. And so we can see that it was going to put 2 shards on server A and server B if we ran the reconfigure, but it hasn't actually changed the configuration of our table, and we can confirm that by going back over here to scores And scrolling down to the bottom, we can see that server A is still the only server that is hosting this table. So that's the answer to Slava's question. And it looks like we have a couple more questions.
So the first one I'm seeing from Nick. Can you talk about any scalability and durability changes? I'm mostly concerned with durability between data centers. Our durability model is actually, well, let me first tell you a bit about the architecture. So we use a primary, secondary replication scheme. And what that gives you is that we have immediate consistency. And you can run queries such that you get hard durability, which means that if a write is confirmed, you can be sure that it has been written to disk. This is actually the default in RethinkDB. This, of course, has some implications for availability. So if a server goes down or you have a network partition in your cluster, you do lose write availability, if at least if the primary for a table is affected. You can still do reads if you do not necessarily need the most up-to-date version of your data. With respect to scalability, so you can use sharding and replication in RethinkDB to distribute your data. And actually, if you run analytical queries, they will be automatically distributed over multiple machines. I hope that answers your question.
Okay, and it looks like we have another Changefeed question from Daniel Cannon. And the question is, how is the performance of Changefeeds when there are multiple clients all listening for changes on a single table? And how does this scale with multiple nodes?
All right, so this gets a tiny bit complicated. So basically the rule is if you do a write on a particular shard, that shard, before the write completes, is going to have to do work proportional to the number of other machines subscribed to the change feed. To changes on that table, to make sure that they're all aware of the change. So if you have change feeds open on 10 machines, and you do a write on a shard, you're going to have to do 10 pieces of work before the write can complete. Then after that, we release all the locks, and on all the machines that are hosting change feeds, we're going to have to do work proportional to the number of subscribers to send that data out to all of them. But we do deduplicate change feed messages internally in the cluster. So if you're subscribed to 10 change feeds on one machine, you aren't going to send that thing 10 times. And we deduplicate these things internally while we're storing them, so it won't use up too much memory for you.
User from IRC asked us what is the estimated date for the 2.0 release. So we are planning to ship 2.0 end of February, probably around the 27th. So that's going to be pretty soon. Another question by Jean. For those of us that might want to provide RethinkDB with our hosting platform, how can we lock tables down and prevent customers from changing settings? I think this refers to the ReQual admin interface.
So John, currently there is no way to lock the ReQual admin interface. So if anyone has the ability to do reads and writes to your cluster, they can modify the ReQual admin interface as well. We don't have a system right now for providing users with capabilities and limiting the administrative abilities of individual users.
So we're definitely considering adding user authentication at some point, and then you will be able to restrict access to certain tables. This is not yet implemented, though. I'm seeing in addition not the admin UI. So you can lock down the admin UI you can, by disabling it or by using a proxy. That as long as you can run queries, though, and connect to the ReQual client port, you will also be able to change the cluster configuration and have full access to all data at the moment. Are there any more questions?
All right, I think we have answered all of the questions that came up in, oh.
I think there's one more coming in. Or no, okay. I think we've answered it already. All right, then.
Hold on, we're gonna wait for a clarification from John. It's possible we misunderstood his question.
I think we have answered it. Right. Okay. All right. If you have further questions after the after the webcast, you can always drop by on IC or shoot us a message over the various channels, Twitter, Google Groups, whatever you prefer. All right. So thanks again for joining our webcast, and we hope you've enjoyed it and wish you a lot of fun and success.